Welcome back, children. Welcome to Refresh Concepts with me, Dinesh Modi. We proceed further with sums based on probability. Now, children, having learned what are the different types of random experiment and different types of events within that random experiment, let's proceed further. Now, sums based on those random experiment and events. So now we are heading towards the actual probability sum. What this particular sum says, the very first sum is based on a coin. It says that when two coins are tossed simultaneously, find the probability of getting one tail, exactly two heads, at the most one head, and at least one tail. Now, those who have just now refreshed the previous videos, which was based on different types of events for random experiment of tossing a particular coin, or two coins are tossed simultaneously, they might be feeling that, sir, this is what we have learnt. Yes, children, we have learnt, but we haven't learned exactly how to solve probability and get the final answer. So 100% that all those things which we have learned up till now is going to come. In addition to that, there are two more things or two more lines is what we need to add. One is the formula and then the substitution one, right? So we see how a probability sum should be done when a question is given to us. Let's start. When two coins are tossed simultaneously. So once we read what is the random experiment, the random experiment is tossing coins simultaneously. So we write down our solution as when two coins are tossed simultaneously, its sample space is given by, as you all remember, sample space is always denoted by S. So children, yes, from your previous videos, anybody can tell me when two coins are tossed simultaneously? The answer is HH, HT, TH, TT. So what is N of S? N of S is 4. N of S is 4. Number of sample points in sample space is 4. You can also, this being the first one, I'm just writing it every now and then. I won't be writing this particular thing within the bracket. This is also termed as total number of possible outcomes. Total number of possible outcomes. That means N of S is always taken as total number of possible outcomes. Now let's start with the first one. So what is the first event trying to say? What is the first event trying to say? It says find the probability of getting one tail. So we say let A be the event. Let A be the event of getting one tail. Let A be the event of getting one tail. Now, from this particular sample points which are there in sample space, if you can just tell me which sample point is what am I supposed to take? Is this going to come? Indeed, even TH, that is SG and TH. TT will not come. Why? Because the question categorically says that they demand only one tail, and obviously HH is not going to come over here. So let A be the event of getting one tail. So what is the sample points in event A? The sample points in event A are going to be HT, TH. HT, TH. What is N of A then? N of A is nothing but 2. There are two sample points within the sample space. Right, children? Now we come to that particular point which I discussed earlier, just a couple of minutes back. Then probability of any event taking place. So probability of event A. Probability of event A is given by the formula, number of favorable outcomes. Yes, children, you can say even this as total number of favorable outcomes. Total number of favorable outcomes. Total number of favorable outcomes. So what is probability of any event? Probability of any event is nothing but number of favorable outcome upon total number of possible outcome. Total number of possible outcome, which we can always write down as n of A upon n of S. So children, in our further videos and in our further slides, I shall not every now and then write down number of favorable outcome upon total number of possible outcome, but that's the formula. Mind you, this is the formula of probability of any event. What is the formula, children? Probability of any event is nothing but number of favorable outcome upon total number of possible outcome, which shall be presented as n of A upon n of S. So what you need to do is that in a particular sum, if there are more than 2 events being asked, maybe 3, maybe 4, then just write down this particular formula once, and thereafter you can write down n of A upon n of S, n of B upon n of S, depending upon the number of events what we have. So here, if I say probability of A is nothing but n of A. How much is n of A, children? 2 upon n of S. N of S is 4. The answer is going to be 1 by 2. 1 by 2. So probability of event A is 1 by 2. Children, one thing should be taken into mind. One thing should be taken into mind is that whenever we have a number which can be reduced, we have to reduce that particular fraction. Here it was 2 by 4, which got reduced down to 1 by 2. You cannot keep your answer as 2 by 4 and as a final answer. You have to reduce it. If the numbers are not getting reduced further in fractional form, fine. Fine, that's very much fine. But if the numbers are getting reduced, we have to reduce and give the final answer in that particular form. So this was my first probability of that particular event of getting a tail. Right? Let's proceed further with the next event. So let me say, let B be the event. Let B be the event of getting, what have they said? Exactly 2 heads. Exactly 2 heads. Now children, they have used the word, we have seen this in our previous videos, in our previous slides. Exactly means we want exactly 2. So what, according to you, what are the sample points in this particular event B? If you can tell me, HH, HTT, HTT, exactly 2 heads. Can I say exactly 2 head means this? Exactly 2 heads means HH. So it is HH. I can say n of B is equals to 1. What is the probability? Probability P of B is, one can say, n of B upon n of S. As I said, that henceforth, once you can give this particular formula, which we have said over here, number of favorable outcome upon number of possible outcome for the later part of the sum. N of B upon n of S. N of B is 1. N of S is going to be 4. So it's 1 by 4. Final answer, probability of B is 1 by 4. I hope my children are understanding, right? So what are the 2 steps which I mentioned in my very first minute of my slide? I said that formula is what we need to remember. And second thing is, on substitution, if the values are getting reduced, we are supposed to. These are the 2 things. Rest all other things is what we have seen in the random experiment and events, right? This is what we calculate, or this is how we calculate probability of any event. Let's proceed further. What is the third one trying to say? The third one says, at the most 1 head. So let C be the event. C be the event of getting at the most 1 head. Children, again, refresh your concepts. Previously go through all those random experiment and events. We have discussed about at the most, at least. So what, according to you, what do you mean by at the most? At the most means maximum. Let C be the event of getting at the most 1 head. Maximum to maximum, 1 head. Can I say minimum to minimum? 0 head is okay. 0 head will also do. Maximum to maximum is what we need is 1 head. That means even 0 head will do. When I say 0 head will do, what are the sample points coming in this particular event? Maximum 1 head. So again, from the sample space, we are going to see maximum 1 head. HT will come. TH will come. Even 0 head will do. So even TT will also come in this. So it's going to be HT, TH, and TT. Those who are wondering why TT when the question had at the most one head, I can't see any head over here. At the most means maximum one head, minimum 0. So TT doesn't have any head. That's the reason we say TT will come over here. So what is N of C? N of C is 3. What is probability of event? Probability of event is N of C upon N of S, 3 by 4. Therefore, probability of event C is nothing but 3 by 4. Last one, we proceed with what is the last one trying to say? At least one tail. At least one tail. Let D be the event. Let D be the event of getting at least one tail. At least means what? Minimum. Minimum one tail is going to do. Maximum two tail is accepted. Minimum one tail, maximum two tail. So can I say what are the sample points going to be in this event? D will have minimum one tail, HT. Maximum two tails, TT. HT, TH, TT. What is N of D? N of D is again 3. Probability of D is N of D upon N of S. Answer is 3 by 4. Final answer, probability of event D is 3 by 4. Probability of event D is 3 by 4. Children, this is how we do sums based on probability with random experiment, sample space, events, and finally, along with this particular formula, we calculate what is the probability. And finally, I'll just remind you once again, in the very first slide of probability, I told you what should be the minimum value and what should the maximum value of probability. The minimum value is 0, maximum value is 1. Let's once again refresh our concepts. Probability lies between 0 and 1. Probability lies between 0 and 1. I hope you remember, right? So I just wanted to show you that this is how we do sum based on probability.